So I study social media, which means, to a first approximation, I watch people argue. And if I had to pick a group that I think is our invisible college, is our generation's collection of people trying to take these tools and to press it into service, not for more arguments, but for better arguments, I'd pick the open source programmers. Programming is a three-way relationship between a programmer, some source code, and the computer it's meant to run on. But computers are such famously inflexible interpreters of instructions that it's extraordinarily difficult to write out a set of instructions that the computer knows how to execute. And that's if one person is writing it. Once you get more than one person writing it, it's very easy for any two programmers to overwrite each other's work if they're working on the same file, or to send incompatible instructions that simply causes the computer to choke. And this problem grows larger the more programmers are involved. To a first approximation, the problem of managing a large software project is the problem of keeping this social chaos at bay. Now, for decades, there has been a canonical solution to this problem, which is to use something called a version control system. And a version control system does what it says on the tin. It provides a canonical copy of the software on a server somewhere. The only programmers who can change it are people who've specifically been given permission to access it, and they're only allowed to access the subsection of it that they have permission to change. And when people draw diagrams of version control systems, the diagrams always look something like this. Right? They look like org charts. And you don't have to squint very hard to see the political ramifications of a system like this. This is feudalism. One owner, many workers. Now, that's fine for the commercial software industry. It really is Microsoft's Office. It's Adobe's Photoshop. The corporation owns the software. The programmers come and go. But there was one programmer who decided that this wasn't the way to work. This is Linus Torvalds. Torvalds is the most famous open source programmer, created Linux, obviously. And Torvalds looked at the way the open source movement had been dealing with this problem. Open source software, the core promise of the open source license, is that everybody should have access to all the source code all the time. But of course, this creates the very threat of chaos you have to forestall in order to get anything working. So most open source projects just held their noses and adopted the feudal management systems. But Torvalds said, no, I'm not going to do that. His point of view on this was very clear. When you adopt a tool, you also adopt the management philosophy embedded in that tool. And he wasn't going to adopt anything that didn't work the way the Linux community worked. And to give you a sense of how enormous a decision like this was, this is a map of the internal dependencies within Linux, within the Linux operating system. Which subparts of the program rely on which other subparts to get going. This is a tremendously complicated process. This is a tremendously complicated program. And yet for years, Torvalds ran this, not with automated tools, but out of his email box. People would literally mail him changes that they'd agreed on, and he would merge them by hand. And then, 15 years after looking at Linux and figuring out how the community worked, he said, I think I know how to write a version control system for free people. And he called it Git. Git is distributed version control. It has two big differences with traditional version control systems. The first is that it lives up to the philosophical promise of open source. Everybody who works on a project has access to all of the source code all of the time. And when people draw diagrams of Git workflow, they use drawings that look like this. And you don't have to understand what the circles and boxes and arrows mean to see that this is a far more complicated way of working than is supported by ordinary version control systems. Right? But this is also the thing that brings the chaos back. And this is Git's second big innovation. This is a screenshot from GitHub, the premier Git hosting service. And every time a programmer uses Git to make any important change at all, creating a new file, modifying an existing one, merging two files, Git creates this kind of signature, this long string of numbers and letters here, is a unique identifier tied to every single change, but without any central coordination. Every Git system generates this number the same way, which means this is a signature tied directly and unforgeably to a particular change. This has the following effect. A programmer in Edinburgh and a programmer in Tebe can both get a copy of the same piece of software. Each of them can make changes, and they can merge them after the fact, even if they didn't know of each other's existence beforehand. This is cooperation without coordination. This is the big change. Now, I tell you all of this not to convince you that it's great that open source programmers now have a tool that supports their philosophical way of working, although I think that is great. I tell you all of this because of what I think it means for the way communities come together. Once Git allowed for cooperation without coordination, you start to see communities form that are enormously large and complex. Right? This is a graph of the Ruby community. It's an open source programming language. And all of the interconnections between the people, this is now not a software graph, but a people graph, all of the interconnections among the people working on that project. Right? And this doesn't look like an org chart. This looks like a disorg chart. And yet, out of this community, but using these tools, they can now create something together.